All right. So we're going to finish up these notes. So we just have trinomials and grouping to do. And trinomials, this is what we did in the quadratics unit. So if there's not a number in front of the x squared, it's a little bit easier. And actually, it looks like none of them are going to have numbers in front. So these will be easier. And then the grouping we also did. So basically, when we had a number in front of the x squared, and remember we split the middle down, we turned that into a grouping problem. So you've done both of these before. Well, but it also has a GCF. So that number is going to go away. All right, so number 15, we're looking for two numbers that multiply to be negative 24, but add to be 2. Multiply to be negative 24, but add to be 2. And now if you have trouble thinking of those numbers, write all of the ways you can get 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then see which ones, because that's multiplying to be a negative, one of these has to be negative. So, anybody got them? Negative 4 and positive 6. Good. So when we factor, we write n minus 4, n plus 6. Number 16, this one has a GCF. A GCF of W. So when you take out W, you're left with W squared plus W minus 20. So we're looking for two numbers that multiply to be negative 20, but add to be 1. What is it? Positive 5 and negative 4. That is correct. So factoring, don't forget we have the GCF. That always has to be included in your answer. So it's W times W plus 5 times W minus 4. Yes, those are easier. All right, now number 17. This has a GCF of 2a. And then we're left with a squared plus 19a plus 34. So we want two numbers that multiply to be 34, but add to be 19. 17 and 2. Very good. So we have the 2a, that was our GCF, and then a plus 17, a plus 2. Number 18, this one has a GCF of what? X. So then we're left with x to the 4th minus 24x squared minus 25. And this one looks a little different because we have x to the 4th and then x squared. So when we write our answer, instead of putting like x plus something, we're going to put x squared plus something. Or, we're going to use x squared in our factors instead of just x. So two numbers that multiply to be negative 25, but add to be negative 24. Negative 25 and 1. We have x, then we have x squared minus 25, x squared plus 1. And guess what? Look at that middle factor. What does that look like? The middle factor? What does that look like? It's a difference of squares. So we have two perfect squares and we're subtracting. That means it's a difference of squares. So we've got to break that middle one down. Now this one, x squared is a perfect square. 1 is a perfect square, but it's not a difference. So this one doesn't break down at all. Just only if it was a subtraction, would it? So the middle one, do you remember the rule for difference of squares from yesterday? You tab the square root of both, and then you do a plus and a minus. So it would be x plus 5, x minus 5. And that's it. So you always have to be on the lookout for those. We will have a lot of questions where it will have multiple steps that you have to do. So like this one had GCF, just a normal trinomial, and difference of squares all in one. Any questions on these? All right, so grouping is what we use when there are 4 terms. And just like we did before, we split down the middle. Now, these are already going to have 4 terms. You know, when we did the trinomials last unit, you had to split the middle one to make the 4 terms. But you're already going to see 4 terms. So what we do is we split it down the middle. And we take out the GCF of both sides. So if we look at only the left, so ignore this. What is the GCF? X squared. And then I have x plus 1. And then over here, what's my GCF? 4. But if it starts with a negative, you got to make sure that you put the negative 4. And then we're left with x plus 1. And remember, in grouping, what you have here in the parentheses has to match. So if you put a positive 4 here, that would be a negative x minus 1, which wouldn't match. So you got to be looking for that to match. Okay. And then we write our answer. We have x squared minus 4 and x plus 1. But what do you see? Another difference of squares. So that difference of squares breaks down into x plus 2, x minus 2. Because remember, with difference of squares, you take the square root of each one, and then you have one parentheses with plus, one set of parentheses with minus. Difference of squares is a lot easier than the cubes. And that's the final answer. So let's do, we got 4 examples. It's frozen. All right, there we go. So split down the middle. The left side, this one's really similar to before. We have x squared. Then we have x minus 1. You're probably thinking you're going to have another difference of squares, but you're not. Because this one, we have a positive 9, x minus 1. All right, so then we have x squared plus 9, x minus 1. Neither of those are difference of squares, and it's not sum or difference of cubes. So nothing else to do. Number 20, split down the middle. My left side, the only thing I can factor out again is x squared. Then we have x plus 5. What about the GCF on the right side? -1, good. So -1, and then I have x plus 5. So my outsides are x squared minus 1. What is that? Difference of squares. Because we have two perfect squares with a subtraction in the middle. So it's going to split up into x plus 1, x minus 1. Any questions? All right, number 21. Split down the middle. Oh my goodness, it's always x squared. X squared. Then we have 4x minus 5. And then over here, yes, 2 is a common factor, but it's not the greatest one. It's actually going to be 4, but I got to do a -4, because that's negative. And we get 4x minus 5. So then our outsides are x squared minus 4. Oh, that's a difference of squares. 4x minus 5. So that first one we have to split up. Go ahead and write in there what you think goes in those parentheses.
So when it's a difference of squares, like how do you determine that?
Anytime you have a variable with an even exponent, that's considered a perfect square. And then you got numbers that are perfect squares.
Yeah. Okay.
So those are both perfect squares, and there's a subtraction in the middle. Okay. That means difference of squares. Yeah. And so this would be x plus 2, x minus 2, and then 4x minus 5. Try number 22. So this one, Nothing else. So your first step didn't have any difference of squares, no cubes, nothing like that. So 2x to the fourth plus 7, x minus 9.